So, Adidev, what about now? Can you hear me? Ashik, Rizwan, can you hear me?
Yes, ma'am.
Clear?
Yes, ma'am.
Clear?
Yes, ma'am.
Yes, ma'am.
Okay. Then, what all things we learned in the last class? What do you mean by atomicity? Ashik,
Yes, ma'am.
what do you mean by atomicity?
Like how much compound is in that atom?
How much? Not compound. How much?
Metals and non-metals.
Yeah, how much atoms? Okay, number of
Yes, ma'am.
atoms constituting a molecule. Okay, or constituting a compound, that is atomicity. And example for a monoatomic. Prajot, give an example for a monoatomic. Prajot, yeah, unmute. Monoatomic example.
Ma'am, argon.
Yeah, why Prajot is not responding? Yeah. Is there any network problem? Yeah, argon, okay. Then helium, etc. Then give an example for a diatomic, Anne Mary.
Ma'am, oxygen, hydrogen.
Hydrogen. Okay, very good. Then we learned about molecules of compounds, right? Vishnupriya, what do you mean by molecules of compounds? Or what's the difference between molecules of elements and molecules of compounds?
In elements, same atoms constitute to form. Same atoms constitute.
Okay,
In
very good, very good.
compounds, many elements constitute.
Yeah, different
Elements.
atoms of different elements joined together in the case of molecules of compounds, and in molecules of elements, same atom. Very good. Give an example for molecules of compound. Rizwan, unmute.
Yes, ma'am.
Give an example for molecule of compound, molecules of compounds. Rizwan,
Ma'am, sodium.
no, molecule. Molecules means more than one atom, right? Nirubama, molecules of compounds.
Water.
Yeah, water, H2O, then ammonia, NH3, CO2, etc. Don't you remember? Yeah, those all are examples of elements of compounds. Then molecules of compounds. Then what about molecules of elements? Aditya S. Krishna. Molecules of elements. Example for molecules of elements. Hein, Steve, Hadeidi, Fia, Rifa, Savio, Aditya, Haya, Meghna, all of you, switch on your cameras. Hein, Steve, Hadeidi, Savio, Aditya S. Krishna, Meghna. This one, give example for molecule of elements. This one, can you hear me?
Ma'am, oxygen.
Yeah, oxygen molecule or hydrogen molecule, etc. Right?
Yes, ma'am.
Whenever I calls your name, please respond, okay? Then we learned about ions, right? Okay, Rizwan, it's okay.
Yes, ma'am.
Fia, unmute.
Yes,
What do
ma'am.
you mean by ion?
The charged species are
Yeah,
known
very
as
good.
ions.
Charged species are known as ions. And when a compound consists of metal and non-metal, a charged species, and this charged species is known as ions. Then Rifa, positively charged ion is known as Rifa?
Cation.
Very good. Cation. The negatively charged ion is known as Badra?
Anion.
Anion. Then in NaCl, which is the cation and which is the anion? Adidev?
Yes, ma'am.
In NaCl, which is the anion and which is the cation?
In NaCl, Na is cation and Cl is anion.
Yeah, Na plus is cation. When we
Cl
name
minus.
the ions, we add that symbols too. Okay, that Na plus, that is cation, Cl minus anion. Very good. Then we learned about certain other examples, right? For ions, that's in your textbook. Calcium oxide, calcium and oxygen, then magnesium sulfide, magnesium and sulfur, etc. Right? Then what do you mean by polyatomic ion? Anjida?
Yes, ma'am.
Polyatomic ion. Do you remember?
No, ma'am.
No?
A group of atoms carrying a charge is known as a polyatomic ion.
Very good, Melvin. A group of atoms carrying a charge is known as polyatomic ion. Give an example, Melvin.
Yes, ma'am.
Give an example for polyatomic ion. A group of atoms with a charge. Don't you remember? Okay, fine. There are lots of examples, that is NH4 plus, OH minus. I will show that screen once again.
CaCO2.
Which one? Yeah, look at
Ma'am,
this
CO2
example.
minus.
Yeah. CO3 2 minus. Okay, CO3 2 minus. Okay, CO3, that's the molecule. Then 2 minus, it is the charge. Clear? Ammonia. Look at this ammonia. That is NH4 plus. That charge of that ion that we put in the top of that symbol. Okay, NH4 plus, like this. Okay. Here 4 hydrogen and 1 nitrogen, then the charge, that is positive charge. This charge for all these atoms, nitrogen and hydrogen, they are together. That is a group of atoms carrying a charge is known as polyatomic ion. The next one, hydroxide. The second one, hydroxide. OH minus. Okay, OH minus. Then nitrate, that is NO3 minus. Okay, NO3 minus. Then next one, carbonate, HCO3 minus. Then that is bicarbonate. Okay, HCO3 minus bicarbonate. That's a mistake in your textbook. HCO3 minus, that is bicarbonate, and CO3 minus is carbonate. CO3 2 minus. So these all are examples for the polyatomic ion. Okay. That's in the textbook page number 37, the last table, polyatomic ion symbols. Don't you see that? Yeah?
Yes, ma'am.
Yeah. Okay. Then we are going to learn about chemical formula. Okay. Chemical formula. So, chemical formula of a compound. It is the symbolic representation of its composition. Okay. We learned about symbols, right? We learned about symbols, then their atomic masses, etc. Then in this chemical formula, that is a symbolic representation of its composition. We are representing the symbols of elements that is constituted in that molecule. Okay. The chemical formula is symbolic representation of its composition. Okay. Symbolic representation of its composition. So the chemical formula of a compound is the symbolic representation of its composition. Symbolic representation means we are using the symbols of elements in the periodic table to write this chemical formula. Clear?
Yes, ma'am.
So before enter into valency, there are certain things that we need to learn or need to know to write a chemical formula. Okay? For writing chemical formula, we wait. Yeah. Chemical formula. AE, that's a plural form, okay? Chemical formula is a singular and formulae, that's a plural, okay? And we need to know the symbols, okay? First, need to learn symbols. Symbols of elements. Symbols of elements present in that compound. That's the first one. Then next one, the combining capacity of elements. Combining capacity of elements. It means that how an element can accommodate or how an element can join with another element or another atom. That's the combining capacity of elements. So based on this symbols and combining capacity of elements, that helpful for writing a chemical formula. Okay? Then look at this example. The human beings, it can be represented as H. Okay? Human beings can be represented as H. How many arms for a human being? How many arms?
2.
2. Then we are comparing it with octopus. It is represented as O. It's just for an example, okay? To clarify this term, combining capacity of elements. Okay? So, how many arms for a octopus?
8.
8, right?
Right.
So, if one octopus has to catch a hold of a few people, okay? This 8 arms of the octopus and the 2 arms of human beings are locked, right? A octopus catch a few people that can hold by its arms. The 2 arms of the human beings and the 8 arms of that octopus is locked, right? Yeah?
Yes,
Then
ma'am.
how many human beings can hold by this octopus?
4:1. 4.
Yeah, 4. 4 human beings, right?
Yes, ma'am.
This octopus can hold 4 human beings by holding 2 arms. By holding his 2 arms. How can we represent this in the form of a formula? Any idea? Using these symbols O and H for human beings and octopus. Then 4 H is needed for O. 4 human beings is needed for 1 octopus. How can we represent it?
HO4.
OH4.
HO4 or OH4?
H2O, H4.
HO4.
OH4.
Yeah, it's OH4 because octopus is 1, right? This octopus needed 4 human beings, right? So we can represent it OH4. In this way, we are going to learn or write the chemical formula of compounds. Okay? Chemical formula of compounds. Before going to that, this combining capacity of elements, it is known as valency. Okay? Valency. This combining capacity of elements is known as valency. It's a new term for you, right? Yeah?
Yes, ma'am.
Yeah. So the combining capacity of elements, that is known as valency. So before entering into writing the chemical formula, we need to learn valency. Yeah. So valency, it is the combining power or capacity of element. It is the combining power or capacity of an element. We see that this octopus can hold four human beings, right? So the combining capacity of the octopus can be considered as 4. In this way, we are going to write the chemical formula. Then it is used to, this valency is used to find out how the atoms of an element combined with atom of another element to form a chemical compound. It is used to find out how the atoms of an element combined with atom of another element to form a chemical compound. Then it can be, this valency can be considered as hands or arms of that atom. Hands or arms of that atom. Clear? Valency, it is the combining power or capacity of an element. It is used to find out, valency is used to find out how the atoms of an element combine with the atom of another element to form a chemical compound. And it can be considered as hands or arms of that atom. Clear? Ashik,
Yes, ma'am.
can you read this slide?
Yes, ma'am. It is valency. It is the combining power or
From beginning,
capacity.
from
Oh,
beginning.
yes, ma'am.
Yeah,
Writing chemical formulae.
yeah.
Chemical formulae of a compound, symbolic representation of its composition.
Okay,
Valency, the combining power of or capacity of an element,
okay,
used to find out how the atoms of an element combined with the atoms of another element to form a chemical compound.
okay.
Hands or arms of an atom. That
So,
atom.
okay. Valency can be considered as the hands or arms of that atom. Melvin,
Yes, ma'am.
can you read the slide once again?
Ma'am.
Yeah,
Chemical formula of a compound. Symbolic representation of its composition.
hmm.
Valency. The combining power of or capacity of an element.
Hmm.
Used to find out how the atoms of an element combine with the atom of another element to form a chemical compound.
Hmm.
Hands or arms of that atom.
Okay, fine. Then we are going to learn. Now it's learned by heart, or in higher classes, or in next chapter. I think learn more about the valency in next chapter. Next chapter, you are all able to find out the valency. Okay. Now we are just by hearting or remembering certain valencies of the ions. That's in the page number 37. Table names and symbols of some ions. Can you see that? Page number 37.
Yes, ma'am.
Table names and symbols of some ions. Yeah. Here the valency, name of ion, symbols, non-metallic elements, then symbol, polyatomic ions, their symbols. Look at this table. First one, valency. Valency is represented in terms of numbers. Okay, valency is represented in terms of numbers. So 1, valency is 1. There are certain ions, they have valency is 1. Examples, in the case of this metals, first we deal with the metals, then, wait, here it is metals, then non-metals, then polyatomic ions. Those have valency 1. So these all have valency 1. Then these all have valency 2. Okay. So name of the metallic ions which have valency 1. Read. Melvin,
Yes, ma'am.
read. Name of ions, those have valency 1.
valency. Sodium
Yeah.
Na
Sim. Na. Na plus.
Na plus.
Okay.
Potassium K plus.
Okay.
Silver Ag plus.
Yeah.
Copper Cu plus.
Yeah. These all are examples for the positively charged ions or metallic ions with valency 1. Clear?
Yes, ma'am.
Sodium, potassium, silver, copper. These all have valency 1. Means their combining capacity is 1. That they all are metals. They have plus charge. Okay? They all are
Yes, ma'am.
cations. Then, Bhadra,
Yes, ma'am.
read the second category. Non-metallic elements with valency 1.
Hydrogen,
Okay, hydrogen.
H plus,
Yeah.
hydride,
Mm.
H minus,
Mm.
chloride,
Mm.
Cl minus,
Okay.
bromide, Br
Minus.
minus,
Mm.
iodide, I
Iodide.
minus.
I minus. Here hydrogen is only H plus, right? I told you all the non-metals are negatively charged, but hydrogen
ma'am.
is an exceptional case, okay? It is placed in the left side of the periodic table because it has a intermediate properties between metals and non-metals. So it is an exceptional case in the case of hydrogen. It is a non-metal, but it has positive charge.
Yes, ma'am.
And this hydride, chloride, bromide, iodide, hydrogen, these all also have valency 1 and examples for non-metallic elements. Okay? Then Rizwan,
Yes, ma'am.
yeah. Read this polyatomic ions with valency 1. This one.
Atomium.
Ammonium.
Sorry, ma'am.
Okay.
Ammonium. H1.
Huh?
NH.
NH4 plus. Is this clear?
NH.
Is this clear for you?
Ma'am,
Yes,
some
ma'am.
pixels, ma'am.
Okay.
Yes, ma'am.
If it's not clear, please look it in your textbook. Okay. Okay, dear.
Okay, ma'am.
Yeah. Read.
Ammonium NH4 plus 4.
Okay. NH4 plus. Read like that.
NH4 plus.
Okay. Next one.
Hydroxide.
Yeah.
OH
Hmm.
minus.
Okay.
Nitrate.
Hmm.
NO minus A.
NO3 minus.
NO3 minus.
Hmm.
Carbonate.
Hydrogen
HCO.
carbonate. Hydrogen carbonate.
Hydrogen carbonate.
Hmm.
HCO 3 minus.
Okay.
Carbonate.
Okay, that's enough. They all have valency 1. Then we are considering the elements with the valency 2. In the case of metals, it is magnesium, that is Mg2 plus, calcium, Ca2 plus, then zinc, Zn2 plus, iron, Fe2 plus, copper, Cu3 plus. Okay. And in the case of non-metallic, oxide, O2 minus, sulfide, S2 minus, then carbonate. In the case of polyatomic, carbonate, CO3 2 minus, sulfide, SO3 2 minus, then sulfate, SO4 2 minus. Okay. Then valency 3, aluminium, Al3 plus and iron, Fe3 plus. Then in the case of non-metallic, nitride, N3 minus. Then in the case of polyatomic phosphate, it is PO4 3 minus.
Yes,
So
ma'am.
try to remember the valency of certain ions. Okay? Okay?
Yes, ma'am.
This valency is needed to write this chemical formula. Okay? Then there are certain
Yes, ma'am.
rules. There are certain rules for writing chemical formula. Okay? First rule, valencies of charges on the ion must balance. Valencies of charges on the ion must balance. When we take a compound, there are different constituting elements, right? So the valencies of the charges on the ion. The ions present in that compound contain certain valencies. That valencies must be balanced. When we look at the example, it will be more clear, okay? Don't worry. Then it is very simple, okay? No need to worry. Then the second rule, when a compound consists of a metal and non-metal, the name or symbol of the metal is written first. That I already told you, right? When a compound consists of a metal and a non-metal, the name or symbol of the metal is written first. In the case of NaCl, which is the metal here?
Na.
Yeah, Na is a metal and that is written first, right? In this way, every symbol of metals written first. So when a compound consists of a metal and a non-metal, the name or symbol of the metal is written first. Okay?
Yes, ma'am.
Yeah. Then the compounds formed with the polyatomic ions. Polyatomic ions means more than one or two atoms, right? With a charge. They are enclosed in a bracket before writing the numbers to indicate the ratio. If polyatomic ion is present in that, they should be written in the form of a bracket, okay, like this. If ammonium is present, it can be write NH4 plus. Should be write in the form of a bracket. Here look at NaCl, there is no bracket, right? But when we are
Yes, ma'am.
applying this polyatomic ions, it should be write in the form of a bracket. Okay?
Yes, ma'am.
Yeah. Then in case the number of polyatomic ion is 1, only one ion is present in that compound, bracket is not required. So NH4 plus 2, like that, bracket is needed. If only one polyatomic ion is present, no bracket is needed. OH. OH is an example for a polyatomic ion, right? That is hydroxide. That we learned in the examples for polyatomic ions.
Yes, ma'am.
OH is there. But here only one polyatomic ion, that is one OH. So no need to write that brackets. But more than one polyatomic ion, this bracket is needed. Clear? Yeah, I will repeat it once again. This valencies of the charges on the ion must balance. Okay, valencies of charges on the ion must balance. Then second one, when a compound consists of a metal and non-metal, the name or symbol of the metal is written first. Okay, metal is written first. Then if polyatomic ion is present, if only one polyatomic ion is present, bracket is not required, and more than one polyatomic ion, bracket is needed. Clear? 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 Yeah. Any confusion? Any doubt?
Yes, ma'am.
Okay. So all of you please go through these rules. Then again symbols, atomic masses, these ions too. Okay. So when we learn this, we are very much, it is very easier for to write this chemical formula. So from next class onwards, we are trying to write the chemical formula. Okay. It's very easy. Just go through these rules.
No, ma'am.
Then symbols, then atomic masses and valency. Okay. Are you
Yes,
ready?
ma'am. Yes, ma'am.
Okay. For next class, all of you study this symbols, atomic masses, valency once again. Clear? Yeah. Then I think class is still 12, right? Yeah?
Yes, ma'am.
Okay, okay. So, Adil Muhammad? Adil? No? Aditya Nair? Adidev, I will send the notes for you, okay? If any doubt, I will send it.
Okay, ma'am.
Okay, Aditya, absent. Aditya is Krishna.
Present, ma'am.
Afsana. Aman. Aman. There are a lot of absentees. Anjida. Yeah. And Mary.
Ma'am.
And Mary, present. Okay, Arjun.
Present, ma'am.
Okay. Ashik.
Present, ma'am.
Bhadra.
Present, ma'am.
Emil Jacob. Emil. Fia.
Present, ma'am.
Yeah. Hadeidi.
Present, ma'am.
Hadi Amin.
Present, ma'am.
Hadi Amin. Haya Fatima.
Present, ma'am.
Hein Steve.
Present, ma'am.
Johan. Johan. John Samuel. Muhammad Rizwan.
Present, ma'am.
Lolita. Meghna.
Present, ma'am.
Melvin.
Present, ma'am.
Muhammad Aman. Nas Parveen. Nirubama.
Present, ma'am.
Nisia. Surya Krishnadas.
Present, ma'am.
Then wait. Adidev, present. Prajot.
Present, ma'am.
Pratyush.
Present, ma'am.
Rifa. Rifa. Rihan. Rose.
Present, ma'am.
Sainaba. Sainaba. Savio.
Present, ma'am.
Vishnu.
Present, ma'am.
Vishnu Priya.
Present, ma'am.
Okay. Rifa, it's okay. So, study well, okay?
Okay.
Thank you all. See you in next class.
Thank you, ma'am.